All right, so we're looking at the Pearson number 31. Okay, so the side of a cube is increasing at a constant rate of 0.2 centimeters per second. As soon as you see, this one was out calculator okay. As soon as you see something like a rate and it says centimeters per second, that is a related rate, okay? That's right, whatever you want to call it. I said dx dt. You could use dSTT for the side. And then in terms of the surface area, S, what is the rate of change of the volume of the cube? Okay. So what I did was I just wrote down, like, here's surface area. I know surface area is going to be 6x squared. But what I really want to do is I want to know what's the rate of change of the volume. Now, I know I have it there, but just think, well, what's the volume? Notice it didn't give it to you here. So I have a sheet with geometry formulas there, but it's just x to the third, right? So d dt of both sides. See, whenever we want to find the rate of change of something, just think, okay, what am I trying to find the rate of change of? Oh, the volume. Write down the volume formula, and then just automatically d dt of both sides. If you know something's constant, you can plug that in, but don't plug in too soon. So I get dv dt is equal to 3x squared dx dt. Now remember, right, s is equal to 6x squared. So you have to try to relate this to somehow the dv dt. So all I did was I just recognized, well, 6x squared is just, that's 3x squared times 2. So this is really 1/2 of s times dx dt. Because you see how there's an s in all of my answers? So I need to figure out some way to rewrite that. So ds dt, or sorry, 1/2 s times dx dt. And dx dt, now we can plug that in as 0.2. So
now,
basically,
how would we originally know that dx dt is 0.2? Do we just define it as
you have to read it in here. In fact, something I've been telling the AP class is on the free response, when there's a related rate problem, usually just writing down like dx dt equals 0.2, dv dt equals 1.8, or whatever it might be, you get a point. Just by writing, just by interpreting what they say in words, turning it into a related rates with symbols, okay? Anything else on this multiple choice?
Yeah. There we go. I have question 40. 40 I got stuck and I can finish solving it. And 44. No, 44 is fine.
Okay, 40. Okay. Which of the following is an equation of the line tangent to the graph? X to the 6 minus x to the 4. Okay.
And I know that.
So basically this is, so I know I have all my work up there, but here you have the slope.
I got to this part, but I couldn't find this from this, and I didn't know how to solve this.
Ah, it's a calculator problem.
Yes, but I didn't know what to do. I plugged it in. But
Okay,
I
so
don't know
here.
how to do it.
Let me quit this program. Okay, so I'm going to go to my y equals. Now, one thing, I could take this and move everything to one side, set it equal to 0, and look for the 0. Or you can do one as y1 and the other side is y2 and look for the intersection. I personally like to move everything to one side.
Oh, man.
So 6x to the 5th.
Totally forgot.
You totally forgot. And then it's going to be a plus 1. And I'll just zoom 6 to put it in standard. And right here is my 0. Yeah, anytime you have to solve an equation and you have your calculator available to you, set everything equal to 0 and find the 0. So here I'm just going to go lower bound, upper bound, and there you have it. Yeah, because take the equation that you had. Yeah. Okay. Because you want to solve for x. You want to see. So basically what they gave us the slope. And what we needed to do was find the point of tangency. So if I know my slope and I can find the derivative, then I can find my point of tangency. So if you set those equal to each other and solve, the x coordinate will be our x coordinate for our point of tangency.
Mm-hmm.
Plug it back into the original and you'll get your y coordinate.
So -1 is the slope of the other x tangent.
Correct. Which if you look at your choices, they all have a slope of -1. It was just a matter of finding. There is there another way to do this? I'm trying to think. Probably not this one.
Wait.
What's that?
No.
All right.
I never actually went over to find out any of them right,
Oh.
but I don't want to take up any time.
The solutions and the multiple choice are on Haiku. Just look for the name Pearson. It's the Pearson multiple choice test. You said 44, Preston?
44, yeah.
You did get 44. Okay. Okay, so if f of x, capital F of x, is an antiderivative. So they're saying f of x, right, is this.
Oh, we are doing 41. Oh, good. I never did.
So if we know f of 2 is equal to 0, we want to find f of 8. So f of, so remember, it's expressed as like the area under the curve. It's kind of like your final position. Your final position is like, or actually no, this is not final position, sorry. This is, you have the, from 0 to 2. Basically this is saying from 0 to 2 of that function is equal to 0. So if I can figure out from 2 to 8, then I'm good to go. It's almost like I need a starting point. So from 0 to 2, the area under the curve is 0. So then from 2 to 8 is going to be 5.163. It's kind of like you need an initial condition. You need an initial condition in order to solve. Now you could have done this very differently. You could have done the whole U substitution. I wouldn't even bother because you have your calculator available to you. So you could have actually done the antiderivative for that using U substitution, plug in 2, 0, and then solve. Too much work. Not necessary.
Now our programs, they seem to take quite a bit of time to do. When do you recommend we use them? I know, of course, for the
if it's on a free response one and you have time to check your work, I would. Otherwise, I wouldn't use the programs. There's not that many places where you would actually use the program. So.
We want something that has the same tangent.
Yes.
We just graph both.
There's a couple things we could do. Yeah, so tangent means the derivative, right?
Mm-hmm.
So I showed you guys how to do the derivative of something. Like let's say you wanted to do the derivative of, you could do math 8 And then you can, and I showed you how to put y1 in there, right?
Mhm.
So we went to variables, go over to y variables. It's a function with y1. And that will graph, there's the original function, and then we'll graph that function's derivative. Hopefully.
So do that,
Now, we'll also draw tangent lines. It comes, so that's what my derivative looks like. If you go to second program, just so you can see, where it says draw, so second program. I don't know why it's taking so long. There we go. You see where it says, it'll take a, so it says tangent? We can type in, so it jumped to my original equation. So let's say I want to find the tangent line at x equals 2. Just type in 2. It'll draw, there, they'll go at my slope, y equals 432x. Just type it in. Are you on your graph? Just put 2. Just type it in what
that
number.
would be instead of going.
Here, let's try it again. Let's do.
It would have to be dx, right? Or this is-
Right, I know my derivative at, so let's say I did, so once you have it, I just want to type in 1.
Do we need the derivative line?
There we go.
In there?
So when x equals 1, my slope is like 18. So there's my tangent line.
Now,
Y equals 18x minus 15.
my question is, back to the y equals part, do we still need that derivative in there?
No, you don't need that.
Will-
but
will it work? The
here's-
broad tangent, will it
Well,
still
that's what I
work?
was just going to say. So here's the neat part about this. So if I were to go to my graph, and let's say I wanted to figure out the value, oh, I think I was on my inner curve. If I went to the value of y2 when x equals 1, I should get 18.
I'm not sure.
Here, hold on, I'm gonna just graph. This was my derivative graph, is what's gonna come up now, apparently.
So
Okay.
for that broad part, we do
Hopefully.
not need the lines for there?
No, you don't need it. You can erase those lines whenever you want. So here was my derivative. So if I do second trace, maybe again, and I do the value when x equals 1, I should get 18, which I do.
Wait, what did you say?
I was just showing you that, like,
Got it.
because that was my derivative, so it makes sense that that would be the same. Okay, so are we okay with 41 then? Okay. Anything else? You want to look over the rest of this packet and see? We're a little less than 20 minutes.
I guess related rates, but this is hot, but, in the volume, I haven't done a volume of a curve with a circle in a while.
Okay.
I know where
Did we
from.
finish the 2014 free response?
No, there was one that I threw
Was there-
away last night. It might have been the 2014 one.
Because there was one of these that rotated, number 2. I thought we did number 2 together, part of it.
I think it was the one that just because there's too many creepers and couldn't close properly.
Well,
13.
I may have an extra packet. What's that one, 2013? Well, what happens every year is, like, I print out so many different packets, as you can see. 'Cause some students want lots and lots of work and others don't, but I just printed out for everybody.
Okay. Where we going?
There might be one
Right
in
there.
the,
There we go.
over there.
Got
Oh,
it.
right in the front. Okay, so number one we did all together, right? Did we do number two?
We did all of them.
Well, I don't know if Ben got all of them, because you came to my AP class. 6, okay. So maybe we can pick, do you have other free response there?
Yeah, 2009.
Oh, well, 6 is like what we were just talking about with the solution. Like where you separate the variables and you move the cosine, or leave the cosine, but move the 3 minus y to the other side. But this involves a u substitution. Does that sound familiar? Because I'll have 1 over 3 minus y dy equals cosine of x dx. Because when I do this, I have to let u equal 3 minus y, so du is negative dy. I don't have a negative, I just have a dy. So basically it's like this. The right side doesn't need substitution. What's the antiderivative for 1 over something? Good. So it's negative ln of absolute value of u.
Mind if I go and get some water?
Go for it. Do you understand? I replaced the u with the 3 minus y right away. And then the antiderivative for cosine is, and then we get a plus c, right? And then you plug this back in to figure out your c, and then you solve for y. Do you want to try that wall? Or do you think you're okay with it? We're still working on it. I found, Preston, I gave you the 2009 free response yesterday. The one that I just gave you guys yesterday. Do you want to do number 4, which is a rotation one for practice?
Yeah, it's just a solid.
Right, but these are cross sections. These are not rotations. Okay, I'll see what I have. Give me. So you got ln of 2, right, and then you get negative ln 2. So now first thing I want to do is I want to get rid of that negative sign. So it becomes negative sine x plus ln 2. And then I want to do e to both sides. So I have absolute value of 3 minus y equals e to the negative sine x. Yeah, there's more practice. Now, when you do stuff like this where you have ln and the exponent, they actually want you to simplify that. Now remember, so it's ln of 2 e to the negative sine x. Now this means, 3 minus y, without the absolute value, could be plus or minus ln 2 e to the negative sine x. No, that's a good one though. What year was that? Say.
This one.
Oh, the College Board practice exam.
Want me to
Yeah.
write on it?
Yeah, I'm gonna give you guys one of those anyway. All that stuff you guys get a copy of.
I guess so.
Does it have to be positive or negative? Has to be positive. So I know 3 minus y has to be positive ln 2. Oh wait, why did I put ln of 2? It's just 2. I'm sorry. Because it's e to the ln of 2, so it's just 2. Yeah, sorry about that. So I'm going to subtract 3, divide by negative 1, and there you go.
Can I get rid of this? It looks like, no.
If you feel confident on all the problems and you don't think you're going to have to revisit any of them,
Honestly,
feel good about them. 45 multiple choice questions. There are 28 no calculator and 17 calculator. So the first section is always the non-calculator part. Okay, so you want me to take a look at the free response. Which number was it on the free response? Sorry, I have to scroll all the way down. It's this one?
Yeah. This is like 3 and 2/3 minutes for each problem. And what's the text? 2.6 minutes.
You don't have,
Fine with that.
and you don't have College Board approved one? Or you?
I thought you were doing it.
SAT? Yeah, that's a good question. Might want to check with college counseling for that. All right, so here's R and here's S. R is the region in the first and second quadrants bounded by y equals 3 minus x squared and y equals 2 to the x. So first thing I would do is label your two graphs. So this is, right? So this is y equals 3 minus x squared, and this one is y equals 2 to the x. Now, it may help you also. This is a non-calculator problem, so we know we're eventually going to need to know where they intersect, right? So I would, do they have anything with where they intersect?
On the volume for the ratio for B, when we find the volume, that's between the non-shaded area and that part, right?
Well, it depends. They're talking about when R is rotated. Well, let's go through step by step here. R is the region. Okay, so we got the two regions. Find the area of S. So how would we find S? Well, S is usually defined as, when you're just doing the area, you do top minus bottom or right minus left. So since everything's already in terms of X, I would do top minus bottom. But the problem is, this curve is bounded on top, but then it switches to the parabola over here. So we actually have to create an integral, two separate integrals for the area. So the problem is we have to figure out where do they intersect. So 2 to the x equals 3 minus x squared. Actually, these were calculator okay. I'm sorry. This was not a no calculator. This is calculator okay. So let's say I set everything equal to 0. Yeah, you need a minute? Oh. So remember, I'm not gonna try to solve this by hand, I just wanna see what are the zeros. So I can actually find, if I set everything on one side, I can find the bounds, which it looks like I'm gonna have to find anyway. Both of them. So I'll just find both of them at the same time.
That's by doing the zeros, right?
Yeah.
Interesting, that intersection zeros there.
Okay, so negative 1.637. And these are all horizontal rotations, so I don't really care about the y coordinate. I'm just saying that sometimes you have to do something rotated. It helps to write both the coordinates, but just because I glanced at it, it looks like everything is in terms of x. Oops, I didn't mean to press that. I got, see this here? 3 minus x squared minus 2 to the x. So I can find the zeros of that.
That's fine, that's good.
Because that'll basically solve my equation. Okay, and I get 1, comma, whatever. Okay. I know you guys have to go, but the first one will be from 0 to 1 of 3 minus x squared, and then dx. And then from 1 to, oh, you know what? I didn't look to see. This is going to cross the x-axis here at the square root of 3, comma 0. Just set x squared, just set 3 minus x squared equal to 0 and solve. And you would plug that into your calculator.
That's time the area of the zeros is today.